So this class is going to be in 3-dimension algorithm, Java, and PHP. First of all, we are going to be starting with algorithm. I'll be using this material here. Firstly, algorithm. There are many definitions for algorithm. The simplest one, so that which everybody can act from what is this material which I'm using. A step-by-step procedure which is defined as a set of instructions to execute in a certain order to get a desired output. We should understand that in algorithm is actually the core of all programming. Algorithm is the core of programming, in the sense that without algorithm, there are so many of the programs which we're having today. Talk about the object-oriented programming. Their core is algorithm, because programs are meant for us to define, to actually get an end product to problems, and for us to implement them, algorithm is needed. That is why it is being stated here that algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order. Another definition which I'm going to use, which is actually not on my screen, which I wrote down here, is algorithm is a finite set of instructions that defines a sequence of operations to be carried out to solve specific problems of a class of problems. That is another definition of algorithm. So understand that there is a word which I would like us to take note of here, which is called finite set. A finite set means a set which can be counted and can be counted finish, in the sense that an algorithm, understand that algorithm must have, number one, an algorithm must have a beginning and it must also have an ending. These are the two important things which you understand about algorithm. When implementing or when writing an algorithm, you have to detail your algorithm in such a way that after each iteration is being carried out, iteration here means step. After each step is being carried out, the next step follows. If in a situation whereby your algorithm is not explicitly defined, you get what is called a loop. A loop in a situation whereby the program keeps running. It keeps running because you have not explicitly given it instruction on what next to do after each iterations. That is that for algorithm. So from here, we're going to, because of data structure, we will be considering some sets of algorithm. These algorithms are some things which most of us, in one way or the other, we might have gotten across to in one way or the other. First algorithm which we will talk about here is called search algorithm. From my screen here, search algorithm. Search algorithm is an algorithm to search an item in a data structure. For instance, in a data structure now, let's take for instance your database. You want to get out an information or a data concerning something. You understand that your database is a pool of information, is a pool of data. There are so many data which you can get, which are actually there. Let's take for instance now, this is actually 300 level. We are having different students from different centers. JPTS, in the JPTS admin, your information are being collected there. We have 300 level computer science, we have 300 level business admin, we have the 300 level database healthcare management. These are all data. So let's take for instance the admin wants to get something, wants to pick out a particular information of a particular student. In this pool of data, how does he or she get this information? This is where search algorithm comes in. This is where search algorithm comes in. Search algorithm is actually used to pick points to locate a single information, a single data or single information from a pool of data. Then this next one here is called sort algorithm. For your sort algorithm is used to differentiate each information. I'm still going to use the first instance which I used when I was explaining while I was explaining search algorithm. For your sort algorithm, you are having different in your 300 level. You are having different classes, different departments. So for your sort, this is where your sort algorithm comes in. Your sort algorithm is used to differentiate each information to their various outlets. You can't expect to get 300 level computer science information in a business admin pool. Although all of them are in the same pool, but you understand that these things are shared in what we call rows and columns. So that is that for sort algorithm. Sort algorithm is used to sort items in a certain order. So you know that in a 300 level, you have different departments. So each of this information goes to each of their rows and their columns in a certain order. So in that certain order, again, you could have the first person that was first given admission, his matric number will be on top, followed by the next person, followed by the next person, just like that. Then the next one, which is here, is insert algorithm. Algorithm is used in a situation whereby you want to input a fresh data or you want to correct an existing information in a database. This is where sort algorithm comes in. In a situation whereby there is an intake of a new student, perhaps in 200 level or 300 level, then this is where insert algorithm comes in. After every registration and everything is being made, then now he or her name is then being inserted into the database, into the pool. Thereby, the system now recognizes this entity now as a legit student of the institution. Then the next one here is called update algorithm. Update algorithm is in this situation, most of the times people mistake it for insert algorithm, but update algorithm, most of the time it's actually different. For your update algorithm, let's take for instance, a student fails a course. For your update algorithm, this is where your update algorithm comes in. Update algorithm, it's used to actually classify or to actually know when a student or when an entity makes a rectification for something. You fail a class, you fail a course. You have to come back to repeat that course. So when you are coming back to repeat that course, after clearing this course, then it is now being updated. Most of the times, these things are done automatically. So automatically, after finishing or after passing this course, so this update algorithm will be used to indicate that, okay, at social time, at the first instance, you failed this course. Then at the second time, you came back for this. So here it is defined that an algorithm, an update algorithm, and it is used in a data structure for an existing item, for an existing item in the data structure. Then the last one here is delete algorithm. Algorithm to delete an existing item from a data structure after passing out from from perhaps, let's say for instance, you are working in a company and you decide to leave the company. Your all your information in that company, for a good data computer administrator, what he or she should do is that all your existing information now, which I mean, perhaps you might be having access to a computer which you use to work. That is the organization's computer which you are using to work. The computer administrator, what he or she has to do is that since you have left the company, he or she have to delete your information. For instance, the company is using biometrics to get access access into the company. Whoever that is in charge of it should also try as much as possible to delete your information, that is to delete your fingerprint. Because most of the times in these days, there are so many things attacks which are happening, and we discover that most of the times there's something called disgruntled employees. Disgruntled employees are most of the employees that, out of anger that the company which they left might not have actually deemed fit to do what is necessary to them, giving them what is actually necessary to them before they left, they might begin to try to come up with something like revenge against the company. So this is a clear example of where delete algorithm is actually needed. So from there we go to what is called characteristics of algorithm. We should understand that algorithm itself, it has characteristics. It have pattern in which it is being done. The fourth characteristic here is unambiguous. Unambiguous. Unambiguous here is being defined as that every step along your algorithm should be well explained. Every step should be explicitly explained. Your algorithm should start with number one. After the step number one is being carried out, what's next? So unambiguous here is defined as algorithm should be clear and unambiguous. That means it should be clear. It should be well explained. Each steps of or phases which are their input and output should be clear and must lead to only one meaning. You are having different steps for an algorithm. Let's take, for instance, you are building up an algorithm for an alarm. And specifically, you only want a single individual to be visiting you. So for you to write this algorithm for this alarm, the first step should be, if there is a knock on the door, you should ask. That is, now the alarm should ask, who are you? And if the name is being given David, allow the entity to gain access. But if not, deny access. This is just a clear example of an algorithm. So your first step should be, when there is a knock on the door, ask for name. Then step two should be, if name is David, then 3 will be grant access. 4 will be else. else deny. That is to say, for your back to your number 3, back to your number 2, which states if name is David. In this situation, only the name David should be given access. Only the name David should be given access. In a situation whereby another name comes in, let's take for instance Daniel, and 4 means deny, 3 means grant access. Grant access only for David. But if it is not, then number 4 comes in. In this situation, this algorithm is well explained, because of course it is only David can be granted access, and then before David can be granted access, there should be a knock on the door. So this is what is called unambiguous. Your algorithm should be well stated. Every step along the way should be clear. In a situation whereby after one iteration is being concluded, then the next iteration automatically comes in if the condition is being met. That's for unambiguous. Then the next one here is another characteristic for algorithm here is impute. That is to say, an algorithm should have 0 or more well-defined input. Your algorithm should have 0 or more well-defined input. Of course, if nothing is being written for an algorithm, then there will be no it won't exist. So another characteristic for it is input, in the sense that your algorithm should allow input. Then we go down to output. An algorithm should have 1 or more well-defined output and should match the desired output. That is to say, at the end of the day, you are creating an algorithm. To solve a problem. And this problem which you are trying to solve is your desired output. So at the end of the day, each of the inputs which you are putting in, at the end of the day, they should all come out to be your desired output. All of them, all the inputs which are going into the system should, at the end of the day, get to solve the problem which this algorithm is being created for. Then the next one there is finiteness. The meaning, I explained this word when I explained this word while I was defining algorithm. The meaning of finite set means that every algorithm should have what is called, should be able to be counted. That is, each of the steps along the way should be something that someone can be able to count. And it should have something that is called, at the end of the day, it should terminate. So it is just like you are counting 1, 2, 3, 4, and at the end of the day, it stops at 7. Finiteness means algorithm must terminate after a finite number of steps. So your algorithm should be well detailed, well numbered, that it starts from 1, which it starts, go to number 2, 3, 4, like that. Then it gets to the last one, then it has to terminate. If terminate. This terminate is very, very important because I've the opportunity to see some programs which it is just this termination that have actually caused it to be what is called a loop, like I explained before. A loop comes into play where in a situation whereby if your algorithm is not well numbered, if it is not explicitly explained, that means if each iteration, each steps along the way the program does not understand it. So at the end of the day, you have what is called a loop. It starts and come back. It starts and come back. Then the next one here is visibility. Visibility. No matter the kind of algorithm which you are writing, try as much as possible to know if it will go along with your resources, available resources. Available resources now means here most of the times in this situation we are talking about your hardwares. Your hardwares. For instance, you are talking about should be mentioning as one thing we should mention here is your motherboard. You understand that there are a part in the motherboard which is called the processor. The processor. If the speed of your processor is not on the high side, most of the times your algorithm won't function very well. So in writing an algorithm, you should take note of the hardware which is in place, the available resources, because most of the times this is actually where you have so many delays. Perhaps you are writing a very high-end algorithm and your processor is somewhere on the low side. Let's take like 1.0 or 1.2 gigahertz. And this algorithm which you are writing is something that works, something that have to be on the speed. If your processor, regardless of whatever RAM or space you might be having, if your processor is bad, if your processor is not on the high side, it will definitely suffer loss. Then the last thing here is independent. An algorithm should have a step-by-step direction which should be independent of any programming code. Your algorithm is different from your programming language. It is different from your programming code. You are only implementing your algorithm using a programming language, but understand that it is actually independent, meaning that it is not stick to one programming language. You can carry out a single algorithm on your Java, then you can still replicate that same algorithm on your C++. You can still replicate it on your C#. You can still replicate it on your Python or Jython, just like that. So it is not dependent upon a singular programming language. You can every time go and make a different that same algorithm. You can actually implement it on different programming language. You can implement it on different programming language. So from now, this is perhaps I will give room for questions. Then before I give room for questions, then before I give some assignments concerning what we've done so far. Hello? It's time for questions. Hello? It's time for questions. Okay. Since there is no questions that is coming up, I would like us to take down this assignment. I'd like us to write out this assignment. Okay, before I do that, before I do that, um, you guys are going to submit the assignment. You guys are going to submit the assignment to this email which I'm about to call out. We're going to submit this assignment to this email which I'm about to call out. Sharon Chris 29. Sharon Chris 29 at gmail.com. Sharon Chris 29 at gmail.com. Sharon FHARON Chris CHRIS 29 at gmail.com. Please, you're going to submit it to this email which I've called. Then the first thing here is, what is the first assignment? What is an algorithm? What is an algorithm, and why are they used in computer programming? What is algorithm, and why are they used in computer programming? Then the second question is, why is algorithm important in computer science? What is algorithm? The first question, what is algorithm, and why are they used in computer programming? Then the second question is, why is algorithm important in computer science? I go all over it again. The first question, what is an algorithm, and why are they used in computer programming? The second question, why is algorithm important in computer science? Why is algorithm important in computer science? Please take note of that. I repeat the email again, Sharon Chris 29 at gmail.com. SHARON CHRIS 29 at gmail.com. Thank you so much. And does anybody have any question? Okay, perhaps you might have one or two questions which you might ask me. You could actually also send it alongside me. Hello? Hello?
Fair enough. This is your boy. If he's angry.
Hello, I'm hearing you.
Hello, sir. So how can we submit the
Okay.
assignment? Is
I
it
got
through
a question here.
just...
Somebody said, is that?
She got me and say,
Come again. Hello, I'm hearing you.
Hello, sir. I said, how can we submit the assignment?
Okay.
Should we convert it to document? Just type it. I said, how can we submit the assignment? Should we convert it to document?
yes.
It's document, convert to document. Document,
sir.
convert it to document.
Okay, sir. Thank you, sir.
Okay, no problem. I got a question here. The person said, I need your definition on algorithm. Okay, perhaps you can join us.
Thank you very much, sir. Go back.
Somebody sent me a message. He said, I need your definition on algorithm. Perhaps you were not online when we started the class. Okay, I will do well to explain again. We gave two explanations. We gave two explanations on algorithm. The first explanation is algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. That is the first. It's a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. That is the first definition of algorithm. Then the second definition, which is actually not on my screen here, is a finite set of instruction. A finite set of instruction. The word finite, the phrase there, finite set means it must be countable. It must have a beginning and have an ending. A finite set of instruction that specifies a sequence of operations to be carried out to solve a specific problem of a class of problem. A finite set of instruction that specifies a sequence of operation, a sequence of iteration to be carried out to solve a specific problem of a class of problem. That is that.
Hello?
For algorithm. Any other question?
Yeah, thank you, Mr. Chukuma. And your time is up. This is already 2 minutes past your time. Thank you for the class.
Okay, thank you very much, sir.
Okay, thank you.